Okay, so in talking about data center virtualization and cloud computing, um, one of the things we have to, there's a couple of key concepts here that we need to understand right off the bat. Um, Hyperconvergence and the software-defined data center. If you remember from your networking class what a converged network is, that is to say a network which carries all of its voice, video, and data traffic on the same set of cables physically. Not necessarily the same logical topology, but the same physical topology. That's a converged network. We're going to take that concept and push it farther. So what you have today with a modern virtualized data center is hyperconvergence. So what you're going to do is take your hypervisor, and just as on the physical cable in a converged network you had data traffic and voice traffic and video traffic all flowing down the same line, and your routers and switches are kind of paying attention to what kind of traffic it is, but you let the end devices really sort that out. You have your hypervisors. You have, instead of having banks and banks and racks and racks and racks of computers, each computer running a single operating system doing a single job. Each physical machine is host to a type 1 hypervisor, a bare metal hypervisor, and that hypervisor has virtualized not one but many machines, and not just computers, virtualizing CPUs, memory, storage, even the network, so that literally everything is running in software. This means virtual switches, virtual routers, virtual VLANs, virtual trunking, virtual security on all of those end devices, virtual software-defined networking, and eventually a software-defined data center, so that literally everything has been virtualized. Literally everything is running as a virtual machine on type 1 bare metal hypervisors. And this allows us to do some things. One of the things that this allows us to do is provide high availability. High availability and fault tolerance. So that if a host system fails, there is literal or no downtime. With products like vCenter, vMotion, you can literally move a running VM from one machine to another without interruption. You can move storage without interruption. There is some overhead, but you can more or less survive with very little downtime, if any at all. This also gives us some benefits. The system is highly scalable, highly flexible. So you can provision new VMs at will, build out new data centers at will, reconfigure your networking at will, implement new security without actually recabling anything, because there are no cables to run fundamentally. You have to reconfigure the VMs potentially, give them new NICs, give them new VLAN configurations, do all that in your virtualized network infrastructure, but it's still virtual. This speeds everything up, because we're going to do all of this with type 1 bare metal hypervisors. So Microsoft Hyper-V Server, or VMware ESXi hosts, vSphere, and this allows you to use allows us to give a single VM a large number of virtual CPUs, up to 64 potentially, and up to 4 terabytes of memory. Now, when I say 4 terabytes of memory, I do not mean 4 terabytes of storage space. I mean 4 terabytes of RAM, which should give you, knowing what we do with RAM and knowing how much space that is, that should give you some indication of how much load these systems are handling, if they need and can use that much. This also gives us backup opportunities, backup possibilities, disaster recovery, Anything less than a total loss of a site would be fairly recoverable because you can just move things around. So we're going to talk next about vCenter, its features and performance. We're going to get into some of the nomenclature. We're going to learn what ESXi means, and then go from there. So thank you for watching.